Cool. For O3 frog jump, a frog is crossing a river. The river is divided into X units, and at each unit there may or may not exist a stone. The frog can jump on a stone, but it must not jump into the water. Makes sense so far. Given a list of stone positions in units in sorted ascending order, determine if the frog is able to cross the river by landing on the last stone. Initially, the frog is on the first stone and assume the first jump must be 1 unit. If the frog's last jump was k units, then his next jump must be either k minus 1, k, or k plus 1 units. Note that the frog can only jump in the forward direction. The number of stones is greater than or equal to 2 and is less than 1100. Each stone's position will be a non-negative integer less than 2 to the 31st. First stone's position is always 0. Okay. To me, this screams, excuse me, this screams graph problem. Yeah, I mean, this is just a graph problem. You have to hit all the stones. Yeah. Well, okay. So I mean, definitely this screams a graph problem, but in a way, it's also a dynamic program problem in that, or slash memorization, because that's probably how I'm going to do it. Yeah. I mean, the states in this one is because you only move forward, so the question you would ask at every step, and because you always have to land on a stone, at most, you can only do 1100 jumps, right? And so the states are kind of, well, what stone are you on and what number jump you're on, right? So basically, so yeah, that's a two-dimensional dynamic programming, and given that n is less than 1100, what was that, like 1.2 million or something? Yeah, I mean, I would, and yeah, and most of that is a sparse array, so you can maybe do some funky stuff with like using a hash map or something instead of a full table. Yeah, I think I'm going to do that way. So actually, do I care now? Okay, now I don't care too much to make it, because I think you could actually just do it with. Well, okay, so this is dynamic programming, and I think actually there's a couple of points I want to make here. So there are two ways to do it, right? One is kind of like, okay, I mean the recurrence is kind of straightforward-ish. Is that so your question that you ask at every step is, can I get to the end currently, let me make it grammatically correct. Given the current position I'm in is stone I and I'm on jump K, right? So that's kind of your dynamic programming problem. And the way to solve this is, well, so let's say that's your f of ik, right? Yeah, roughly. So that question, to answer that question, you have to answer, well, can I get to the end given that I'm on stone, some other stone j, given that I'm on k plus 1, where j is equal to where the distance between stone I and stone j is what is it, k, it's either k minus 1, k plus 1, right? So that's kind of your recurrence, and then this is for any, I guess, I don't know how I'm denoting it really well, but for any j, right? or something like that. And this, so you could definitely do a memorization, as I pointed out earlier, because this is a very easy recurrence to write, and then you can, and then you end up with this probably essentially a sparse matrix, and that's fine, right? That's n squared, and it's that's n squared time, n squared space. Yeah, n squared time, n squared, well, definitely n squared space, n squared time, and then you get the answer, right? So that's kind of like the solution that I think people would probably generally be happy with in general. And then the next question after that is, can you do better? And with dynamic programming, it turns out you can, right? I think the thing to notice is that for every k, you only deal with the last k, or for every k, you only deal with the k minus one row. So you only need to keep track of the two rows, right? The current row and the previous row. And in that case, yeah, so in that case, yeah, I mean, so yeah, so in that case, the running time is still n squared, so it's still quadratic, but the space complexity is just over n because it's just you're only keeping track of two rows, so it's just 2 times n, which is over n. So that's something that to keep in mind of, even if you don't end up implementing it that way, because that way is a little bit tricky to wrap your mind around unless you get a lot of like a lot of practice, or just have a strong intuition about dynamic programming, which sometimes I'm a little shaky on, to be honest. But at least it's something to kind of think about in terms of explaining to giving as much as you can to the interviewer. So I think that's what I'm going to try to do with the dynamic programming way. If not, then maybe I'll fall back to a memorization. Who knows? Cool. So yeah, so that's kind of how I'm doing about it. I think everything else is roughly straightforward. Well, given that we already knows this, so. This is Max Stones. And just 2. Well, I guess this is technically a bool, but actually. Okay. And then I need to initialize INJ. Okay, cool. So I'm just initializing the variables. And then now to kind of kick off with the first row. So let's just say you have an I, and instead of using J, I'm just going to use K. Just because. Yeah, okay. And there are ways to kind of there are ways to even further optimize this because because you have lookup tables for this, but I'm okay. I think I'm just going to be a little bit lazier here and not do premature optimizations. I'm going to see how far I can get first. It's just okay. Something like that. And first of all, your this is your recurrences base case. So basically, you're saying that you can always get to the 0th stone, which is always value 0. I think it even points out the thing, which is actually a nice thing that they did for you because you could probably just set up the standard anyway. It's not a big deal, but at least now you don't have to. And the k is 0, right? Okay. So, okay. and so actually K should be starting with the first jump. Because, yeah, because on the 0th jump you're already at 0. Okay. Oh, you actually do need that optimization, I guess. Yeah, so the thing that I forgot is that if you don't use that optimization, then you would have something like you could go for all of J, but actually, yeah. So okay, fine. But each stone can only be connected to at most 3 stones, right? So we can just kind of create a list that way. Actually, yeah. How do I want to brand it? Okay, maybe I'll just use Python then. So then I could use adjustable lists. Oops. And I could actually play around with this a little bit more. Don't want to do this right now. Okay, fine. I don't need this. I have to double check that I'm not off by 1, but that's fine. Okay. So, oh yeah, so now we're doing the thing where we have to quickly find the things that I is connected to. So let's just actually comment this out for now. And then now we should build up the kind of the graph part of this problem, which is create the sparse graph, right? And you know that for each of these stones, it could be only connected to at most 3 stones in a forward position in a DAG kind of way. So adjacency list is the best way for this, because then you know that at most you have 3,300 elements stored somewhere, right? So that's kind of that's what I'm going to try to do. Yeah, I guess technically I actually don't. Yeah, okay, whatever. Why not? Oh man. that just creates the default empty adjacency list. And now we have to kind of go through all possibilities, which, I mean, I'm trying to, I mean, you definitely can kind of, given that this is actually a sorted ascending list, you can actually use binary search to kind of just find if the three numbers are on the list. But actually, no, you don't even need to, because it's either k minus 1, k, or k plus 1. So you can actually just have a hash table. So let me just create a set. Actually, maybe do I even need an adjacency list? No, we just need a reverse lookup table from the stone number or stone position to the index. So that's probably fine, actually. So you just need a reverse lookup table first. Always call it map, but I always forget which one is which. So I'm going to just run this real quick. So this will complain because now that's going to print a lot of random stuff. Okay, fine. Oh, oops. Okay. Just wanted to test because I always forget the order between these two pairings, but that's all you need, I think. If stone sub, oh, what the? I don't even need that. Maybe plus 1. I'm not quite sure about that one, but that should be okay. If stone sub I is plus k, that's possible. Wait, I want to do this. Oh, minus k? Yeah. It may also be off by 1. That's possible. This may be a little bit hard to read actually, but I'll try to do this for now. No, this is. Or someone like this will get you one iteration. Reason why I'm fixing this because I'm going to print it out and I don't want to print thousands of entries or something. But so this is after one iteration. Then after, also my for loops are wrong. And now, as possible, I know, give me a second. Also, this should turn all this back to real booleans. But before that, if the last one, is it? No, I guess I just do -1. Something like that. This is a little weird because this should not have been true twice. Well, let's see. Right, actually, is that true? K plus delta has to be greater than 0. Okay, so it doesn't stay at the first one, but 3 should go to 5. I mean, I think there's just some reference stuff that's a little weird. Okay, fine. Why did I not print this? Oops. Okay, so this is roughly slightly better. But first one, second. So I should be able to jump to the third stone, but It also jumped to the 4th. Well, I mean, this path doesn't work, but there should be another path. Maybe my delta is a little off by 1. 2 jump, 3 jump. So this should be true in both these cases. So I'm probably just having an off by 1 somewhere a bit. Is either that or just not checking at all, but let's see. This end statement is not necessarily needed, but I'm just putting it so I could kind of make the debug easier. Yeah, so 3 connects to 5. That seems okay. But maybe my I as well? Yeah, that's weird. Because the third index should be true. Not, oh well. Instead, it's the 4th index. Did I do I wrong? Oh, I'm moving I instead of. No, is that right? Stones of I, because this means that I is connected to this thing. This should be okay, but very well. I guess I might as well print everything. This is the third jump. I'm just reading this again and yeah, okay. So 3 is connected to 6. No. 3 is connected to 5. Man, I definitely have an off by 1 here somewhere then. because I is 4, but the stone is the 5th. 1, 2. Yeah, am I going crazy? Why is there 4? Oh man, am I looking at the wrong problem? All this time, huh? Where does this even come from? This is okay. Well, I was driving myself mad because I'm looking at this example 1, but apparently the default test case is actually not example 1, which I mean I guess it's a thing that happens, but I just didn't even contemplate it until I really pointed everything out. Okay, well, now that I checked a lot more, let's see. I don't need this. Okay, so this is true. Okay, I don't need to print this anymore. Okay, so this is true, right? Don't know why there's an extra for loop. Oh, I guess that's before we check the. Oh, that's actually funky. I should swap it after we check that it is possible. Oops. That's actually a potential bug, or a probable bug even. Okay. Well, now we test the right code with the right examples. Let's try a few more. Oh man. Okay, and then oh man, I wish I actually remember what that funky example was, but okay. Let's try a smaller case. Yeah, I'm just gonna submit, and then if I see what the wrong answer is. Okay. Well, let's see what happened here. I don't know why I did that. That changed nothing, but it's probably off by 1 somewhere. It seems like that's something that I'm least confident about, but okay, so given this one, yeah, you should be able to jump out of 1 step, and then 2. The delta plus 1 is not, like, it should be 3 and 4, right? After the second step, you could do 3, so that's weird. Okay, that's maybe my plus 1 is that right? Do I man, did I do this wrong? Does this? Oh god. Okay, I always forget that X range doesn't include the last. It's not inclusive, right? So what I want to do here is for the delta to go from -1 to +1 to eliminate in the problem statement, but I just didn't consider the +1 case. What a silly mistake. And that's something that if you're self-aware of your things, like I know that I get my X range +1 wrong a lot, or phi 1, something that I should have checked for. But well, let's see if it's right first before I make further silly statements. Oh man, okay. I think this is still mostly right though. There's clearly an off by 1 somewhere. Maybe I should have done it with memorization, just so that it'll be less obvious. or like it's more obvious to get it right. But I am trying to practice dynamic programming, especially this type of thing where we get the n square space down to n space. So this is good practice for me, even if I'm clearly struggling a little bit as a result. So my answer is true, but it's supposed to be false. Why? Dum, dum, dum. I mean, this looks okay to me, but clearly not. So after one jump, the first jump must be exactly 1 unit. Is that the reason? This is the case. I'm going to just, I don't know. Okay, at least that's not the case, but still a little bit. Okay, so after one jump, it goes to 1. And then after second jump, it could do, no, it cannot get to 2. Oh, yeah, it can get it to 2. So after second jump, these you could get to 2, 3, and 4. And then now the third jump, well, you could do 3, so 8 and 4. So only 8 should be good. And 4 from the 2, but why did I print this out twice? Anyway, so the 4 and the 8 should be possible. Okay, maybe I accept that on the third jump. And then on the fourth jump, four can get, yeah, 8 can jump to 11, and then you're done, right? Man, maybe I'm missing something about this problem. Am I? Let's see. So you could go from 0 to 1 to 2 to 4. Oh, wait, I think I misread something. Okay. Well, this is kind of awkward. I think I misread the problem. It's not. Oh man. But can still. Wow. This changes the problem drastically. Actually, it said that if the Fox last jump is k units, then the next jump may be k minus 1k or k plus 1. And I totally read this problem as on a kth jump, you can only do k minus 1k or k plus 1. So this is actually a totally different problem. Well, that's tough. But I mean, it's what I said earlier is still true with the recurrence. The efficiency. So this is still true, except for instead of I'm on jump k, it's and my last jump is k, right? So now this recurrence is actually instead of this is actually this, or -1 or k. Man, this changes things a lot. Okay, so yeah, so okay, so that's going to be the case. Eh, I don't know why I changed to C actually, but okay. Oh man, I guess you could think about this as kind of solving two problems then. One incorrectly read problem, and then maybe a second, hopefully correct problem. At least one that I could submit for. I don't even know how I pass so many things, but okay. So that's kind of problem statement. So I think for this, I will actually just use yeah, memorization. So that's kind of just implemented that way. So okay, I don't need. So kick it off. Self dot memo is equal to go. I was going to name this Ken Quas, but it already is named Ken Quas Ken. This is a terrible name, but Ken Farquas maybe slightly better. So now the first jump must be 1, and you're on the first stone, right? Okay. Stone and K. If otherwise, otherwise we just implement this. Well, now we need the base case. If stone is equal to len of maybe -1. Okay. And I'll go over the complexity later. This is, yeah, okay. What am I doing? Oh, I still need that lookup table. Whoops. Should not have deleted that part of the code. I think it's easy. Man, my typing has been dreadful today. So now we just kind of implement this part. When now, because we're in K, yeah, let's see if we could jump to 1 self.ken fuck. Okay. So well, at least I'm going to learn from my mistake a little bit. This is awkward looking, but basically you're just trying to get delta to be -101, right? Maybe this is a little weird. Yeah, I'll figure that those edge cases in a bit. So this just gets the index of the stone that you can jump to, and then if that's a stone, then I have to add some checks like. And there's some like weird edge cases where the first jump can actually not be more than 2 spaces, but it'll be okay. And I also have to memorize this, so hang on. This is roughly right, maybe. Oh, whoops. Well, silliness aside, I mean, algorithm should be roughly right. I mean, it fixes this one. I think there's an edge case where this is wrong, is why I have something like 0.2, maybe even 3, I guess. Because I don't check for the first step. How many? Yep, there you go. This is kind of annoying, but that's. Just try to figure out how to do it this way. If there's at least 2 stones, okay. So if that stone is that 1. But that's not sufficient though, because you could still have like something like this, and maybe it's still, I mean, maybe not this particular case, because the 2 and then 3 or something like that. So okay, it's kind of messy. What a weird condition. Okay. Oh, within 4s, but then now I could jump straight to 1 with the last jumping 1. Okay, maybe that actually makes it okay. And I'm just gonna see if I could, just making sure that it's actually getting memorized. Okay, stuff is happening. Doesn't memorize the force part. I guess I would never get there, but okay, so it does memorize. Okay. Does memorize okay, so okay, let me submit again now that I hopefully are solving for the right problem. I guess I should have tested the example cases first. Okay, so that actually works pretty quickly. The test was very fast. Okay, cool. Yeah, so I guess the kind of number one thing you need to do when it comes to these problems is make sure that you read very precisely and correctly. If you had I mean, I spent way too much time on this problem, mostly because I'm solving two problems. Where the first problem is that I thought on jump K, you could jump these 3 units, where actually it depends on your last jump, right? But and while we changed the recurrence very minorly from kind of I don't have the previous one, but to this thing, right? You can see that the implementation, especially with memorization and recurrence and dynamic programming, is a little different. I think you could still make, because yeah, I mean it's trickier, but maybe you could still figure a way to optimize it. Maybe not, but in this case, it is O of n squared space and O of squared time to fill up the entire array. Yeah, and as long as we have the reverse lookup, so that we don't kind of so that we do a linear, or sorry, a constant number of times on each of these on each of these recursions, it should still be n square. Yeah, and yeah, as an interviewer, how do I feel about this? As an interviewee, I'm okay. I mean, I eventually got the answer, even though it took a long time. As an interviewer, I mean, it's a very straightforward. I don't know if it's straightforward, but it's a dynamic program problem with a kind of an optimization thing in the middle where to create the reverse lookup. And you could even do maybe slightly better depending on the inputs by creating an adjacency list. But so there are different ways for the candidate to kind of explore. I could. It's a little weird. It's a little tricky. And if someone is good at dynamic programming or memorization, this is actually very straightforward. So I don't know how I feel about that. I think like trying to gauge like how much information I could get from a candidate. But I think that, this uses a couple of things and put them together. So I think I still would consider it like a good problem to on an interview. I mean, it might not be my type of problem, but I think like I could see myself seeing it on an interview, and it's about roughly on the right level of difficulty. Both this problem and the problem that I accidentally solved the first time. Yeah, so yeah, I mean, I'm not in love with it, but I could also see it getting asked. So I would definitely kind of practice stuff like this. It's relatively standard memorization. You just kind of have to make sure you get the parameters right and kind of the recurrence right. So yeah.